So, hi all. So, this is the lab related to wireless communication. So, we are going to use GNU radio as a tool for explaining the wireless communication scenario. So, myself, Dr. Dhruva Kumar T, and my colleague, Dr. T.R. Satish Kumar. So, in this session, we are going to discuss how to simulate the programs related to basic experiments such as amplitude shifting and frequency shifting. So now let us look at a scenario where how we can simulate a flow graph for amplitude shifting. So the default thing is, so whenever you open a GNU radio, so you're going to see this window here. So default you'll be having the options block as the variable block. So the default it is top block, and all the settings are as it is. So the generate options block is Q2GUI, let it be Q2GUI auto start. So let it be the default options will be same. And coming to the sampling rate, it is default is it is 32K. So now let us look at the scenario. How do we simulate a scenario for amplitude shifting? So we need to pick up the blocks which are available in the right side of the window, which is called as the search window blocks. So we need to look up the blocks such as source block. So just I'm showing you how to pick and drop the blocks related to the source block. So if I search here, source, just you can search for signal source. So here is a block signal source. You drag and drop here. Okay, so this is a block which generates the signal source. If I click on this block, so it says if the sampling rate, waveform is cosine, and you have the options of varying the blocks such as cosine, sine, square, triangle, sawtooth, likewise. And you can vary the frequency as well as the amplitude as well as the offset. So these parameters you can change it here. Okay, so similarly, I need to pick up the blocks to observe the output in the sync here. So let me pick up a block called signal sync. Okay, so just I'm showing the scenario how the signals is generated and how we can visualize this signal here. So just you can click on this output of the signal source, click on this output input of this QT-GUIC. If I connect it, the wiring is done here. So once it is done, so just let us look at the waveforms. So you need to give some wave here, name for this. Let me give this as test. You can give the appropriate location where you can save this file. Save it. Yes. Now let us run the program. So the scenario is generate the flow graph. So whatever the window means the program we have done here, this is the flow graph. So just I am generating a simple experiment just to visualize the source and visualize the output here. If I run this here, so just I am observing the things in the frequency domain. So it says around 1K. The signal is 1K. This is in the frequency domain. Let me check in the time domain. So this is the time domain signal. So it is giving both the real part as well as the imaginary part. So just if you click on this, it gives, so clicking and unclicking gives you real part as well as the imaginary part. So this is the real part of the signal, and this is the frequency domain signal. In the frequency domain, it is in the spectrum at 1K. So just to make the changes, if I can make it 5K. So again, what are the changes made in the program? You have to save it and then run it. So now it says the spectral component at 5K, and similarly you can change the frequency time domain. So it is 5K. So this is how you can use this GNU radio for generating the waveforms. And now if we look at the program to generate the amplitude shift keying signal. So just we have simulated the flow graph for this amplitude shift keying. So for this case, we are using two source blocks. One is this is the message signal. So this is a carrier signal. So the carrier signal frequency is 1 kilohertz, amplitude is 1 amplitude, and this is my message signal. So change this waveform to square type, apply changes, and the remaining options are same. So uh, the frequency, usually the message frequency should be lower frequency, so we have set it to 100 hertz. And then we are using a block called multiply block. So you can pick a block called control F, multiply. Okay, so there's a block called multiply. You can drag and drop. So this is the block what we are choosing here. So one more thing we have to note down is, so like what are the kind of data type what we're going to use here. Just you can see the difference in this color for this data type. So here it is showing blue color. This is orange color. So all these data types are related to the floating point data type. So the orange color refers to a floating point, whereas this is a complex type. So my all the data types should be matched here. That's what we have set all the data types to orange color. So change, you can have the option of changing to complex to floating point, integer, short likewise. Right. So this is how the multiply block is chosen.